My name is Bartosz, but you can call me Bart. I'm basically a QA quality engineer. This is my role in a company called Spartez, and I'm going to talk about code coverage, give some insights into code coverage. So, first question to you: who of you know Spartez? Okay, there are some people, and I see a tendency that those people are from Poland. Because I am from Poland. Like I arrived here from Gdańsk. Have you ever been to Gdańsk? Yeah, it's very similar city to Lviv. Also very old city. The only difference is that we have boats, because the city is near seashore. So we have boats, we have sea. So that's something you need to work a bit on, but no worries. Okay, so Spartez, to those of you who don't know what Spartez is a product company. We develop products that help agile teams do planning poker. Okay, so there is add-on for that, for Jira, and Spartez developed it. So hopefully one day you either use it right now or you will use it in the future. But this is one of 3 products that we develop. But besides that, Spartez is also a partner for a company that you probably know. At least you probably use their software. So there is a company in Australia that has its main quarters in Sydney, and it's called Atlassian. Who of you doesn't use Jira? Right, so I'm not here to accept your support requests, to resolve your issues, nothing like that. Please don't ask me about Jira. Ask me only about the contents of this presentation, okay? Cool. Yeah, so because we are partners for Atlassian, we also help Atlassian develop Jira, Bamboo, Crowd, and Clover. And I'm a quality engineer for Jira. I'm working with a team that is responsible for developing ecosystem, APIs, REST APIs, plugin support, Atlassian Connect add-ons. So you can also talk to me about that, but please don't complain. Okay? Right. So before we start, let me talk a bit what we are going to talk about. So we are going to talk about risk. Let me remind you that the presentation title is something about code coverage, right? So we are going to talk about risk. We are going to talk about tests, and basically tests that you don't have and you need them, and tests that you have and need to use, but you are not sure where to use them, etc. I will talk a bit about that in details later. What we are not going to talk about is we are not going to talk about code coverage. So that might be a surprise of you. Assuming that you know what code coverage is. You used at least one tool that gave you a report that showed you what the code coverage for your code is. I'm not going to explain what code coverage is and what tools you have. I'm just going to briefly mention one tool, walk through the results that this tool gave me, and then explore what you can do with those results. Okay, what you will often see is graphics similar to this. Who of you can tell me what it is? Probably no one. So this is our application, right? This big square is our application. This is not like application, like we are not developing squares, but this is the code of our application. So every rectangle in this square is a package. So who of you knows what package is in Java? Right? So package is just simply a collection of classes, right? So every rectangle in the square is a package that we have in our application. So what you see here is all those packages represented by different rectangles, by different corals, and how many classes they have. So the bigger package, the bigger rectangle, the more classes it has, right? I will use similar graphics during the presentations. Okay, and this is going to be quite a ride. It's going to be a roller coaster. I'm going to speak fast. I'm going to go through a lot of slides. I think I have them 70. And they will be packed with information. So hopefully you won't vomit at least, right? Okay. Let's start by giving you a bit of context. Why we even started looking into code coverage. So assume that you are about to join a project that's all about refactoring your application. So you already have a product, and you are expecting big refactor of this product. So what you do as a QA? You are looking for a safety net. And normally, this safety net is represented as your regression automated tests, right? So as long as you have automated tests that potentially will catch any breaking changes to your refactor, then that's okay, right? And honestly, I was pretty happy with doing this refactor because I know that automated tests and writing automated tests and testing in general is in our company DNA. And when I'm saying in company DNA, I'm meaning in Spartez DNA and in Atlassian DNA. And what may surprise you is that for testing and for automation, QAs are not responsible for testing and automation. Developers are. So we have a lot of automated tests. We have a pretty comprehensive automated test suite. And let me take a break here and explain a bit how this works, like how we do software development and testing in Atlassian and in Spartez. So everything starts with a story, right? Like we are getting a story, we are going to work on it in next sprint. And once a developer takes a story, we are doing a meeting with this developer. We as QAs, right? There is a QA pairing with developer doing a meeting that's called kickoff. So we are kicking off story development. And during this kickoff, we are basically discussing with developer what are the risks behind implementing this particular story. What you are going to change, how this may affect code base, how this may affect the users, what are expectations toward this change. And based on that, we come up with something we call testing notes. And testing notes contain test scenarios, something that developer will need to go through. That's interesting. And all the risks that we are aware of, like for instance, performance might be a risk for this change, and all the open questions that we weren't able to answer during kickoff, right? So we may not know exactly what is expected, for instance, when it comes to how many users will use this new feature. And it's for developer during his development to answer those questions and to use the answer to drive development. Okay, so once we have testing notes, they basically help developer drive coding and also drive testing, right? Because we have these testing scenarios there, so he or she knows what to test. Okay, and once a developer is happy with what he or she implemented, then we are having another meeting with them, and we are basically having an exploratory testing session. So we have this new feature, it's already implemented, it's already in app, and now we are playing with it, right? And the idea is to come up with some ideas that we missed during kickoff. So it happens that sometimes we miss something, and we need to make a step back, make changes to the initial testing notes, and once again code something and do another demo. But most of the times, this is when development finishes, everyone is happy with what was implemented, and we can reach production. And when we are reaching production, we are basically monitoring how the feature is used. Are there any problems with the feature? Because myself, I'm working for a cloud product, so it's very easy to push a new feature and push a change to production to see how it's used. Okay, so you may ask, if everything is done by developer, what is my role there? Like, what am I doing with my time? Why do you ask this question? I say, like, what do you want from me? So it's not that we don't have anything else to do. Like, there are three main pillars of things that we do with our spare time as QA. So the first one is dev education. You can't expect that developers know how to test. You can't expect that developers know how to do exploration. You need to teach them, and it's very hard. I can tell you from my experience, to teach someone else, for instance, how to explore. you hear a lot about exploration, but it's really hard for someone to explain to you what exploration is, other than taking your shoes and hitting a keyboard with them, right? So, and it's not enough for developer to hear that and, oh, okay, I know what exploration is. So you need to explain to him, probably better with algorithm, what exploration is. So we spend a lot of time educating developers. Another thing we do is we are supporting developer in testing. So we are implementing tools for them, frameworks, etc. So they can use to implement automated tests, or they can use to easily set up instances that they will use for exploration. And the third part is about process improvement. So we are responsible for not finding bugs, right? It's not like, no, if we found a bug during demo, for instance, we are doing like very bad job. It's expected from us to not have bugs in the first place. So we need to do everything in our power to understand the root causes of those bugs and fix process so they will no longer occur. So there is a lot you can do with your spare time other than testing. Okay, but getting back to the presentation, just to remind you, it's about code coverage. So because developers automate their tests and test in general, we have this mythical pyramid. So who of you know what this pyramid is? Just one person. Come on. You probably all know what. No, I'm not saying what's the location. What's the? Yeah. No, it's not Egypt. I'm saying like what this pyramid represents. Yeah, software testing pyramid. Yeah. All these different types of tests that you have on different levels, etc. So we have this. In terms of quantity. So we do have about 40,000 unit tests. So those tests at the bottom level of the pyramid, we have around 10,000 API tests, so somewhere in the middle. We have 1,000 WebDriver tests and around 100 system level tests. So quite comprehensive suite, right? So once again, why I'm needing to confirm that we have sufficient safety net. Like, what's wrong with me? We already have so many tests, right? But you will see that the numbers are just not enough. Like, you need to look into what is behind those numbers. Okay, so I wanted to analyze what is the coverage that those tests give me, right? And what you see here on this on the slide is a front page from a report generated by a tool called Clover. Do you know what Clover is? Okay, just write it down. Clover is a tool. I'm serious. Write it down, because Clover is a tool developed by Atlassian, and up until okay, that shouldn't be funny. But up until this year, this tool was a paid tool. Like enterprise tool, you needed to pay like a lot of money to get a license. From this year, it's open. You can download it. You can get a free license, whatever. You can use it for your own projects. So if you want to analyze code coverage, there is no better tool than Clover that is free. And yeah, basically what it shows you is how many of the code in your application is covered by at least one test, right? So you have this number here, like 70.4 or something. Wait, I have it here, like something that I can point. Oh, this thing. So 70.4% of code is covered with tests. So that's great. You have this information from report. And basically, sometimes you have teams that are aiming to have certain code coverage, right? Like, we want to have 80% of code covered, right? Okay, we will talk about that. There is another cool feature about Clover. And it basically, Clover basically tells you what tests go through particular line of code. So you can go to a class, you can select a line in this class and see whether there are tests and what are those tests that go through particular line. And this is not like limited only to unit tests. You can have that information for any other types of tests. Like for instance, if you have WebDriver tests and you are running your WebDriver test against application that is run in external process, you will also have information about what WebDriver tests hit your code. So this is kind of useful, right? And we use that information to build a database of relations between code and tests. So we knew what are the covered classes in our application code, what are the covered methods, what lines are covered, but what type of tests, exactly what test classes, and exactly by what test methods, right? So we had like we have a clear understanding what lines of code are covered and by what type of and what specific test. Okay. So just to do like just to remind people who may not be aware how does the structure of Java applications look like. We are starting with statements, and statements are basically lines of code, right? So in Java applications you may have lines of code. Those lines of code basically are encapsulated in methods or grouped in methods. For methods are basically grouped in classes, so classes have methods, and you may have several classes inside a single file, right? And you may have several files, and those files are grouped into packages. So this is how the structure of Java application looks like, right? Like those are the elements that you have. And what we have in our database is the information what test is passing through a particular statement. But because there is like clear hierarchy between those different concepts, you know what tests go through method, you know what tests go through classes, you know what tests go through files and packages, right? So we have like clear understanding what tests cover what. Okay, and now, you've seen the report, right? It's shown you that the coverage is around 70%. It was just like example of a report that you can generate for your application. It's not that it's the percentage of coverage for our application, but let's assume that the coverage that the report generated was between 80 to 99%, right? So it wasn't ideal, like it wasn't 100%. So what does it mean? Like, is it good? Is it not? Are we missing something? Should we spend time and money to implement tests for those missing 20%? Or should we not? Right? Is it enough? So this is the problem with standard coverage reports. They don't answer those questions. You can look into what classes are having problems with coverage, what classes are not covered by tests, but this tool will not tell you that out of the box. It will just tell you 80% of your code is covered, right? So we were struggling with this problem, and our first approach was to look for low-hanging fruits. Maybe there are packages in our application that are missing coverage, and this missing coverage is really greater than in any other packages, right? So look for those packages that are missing the most coverage, right? Unfortunately, it wasn't the case. And I hope I didn't blow your mind with this picture, but this is a very similar picture to what I presented you on the first slides. So still, we have our application, and every rectangle in this square represents a package. And the size of this package is basically telling you how much test we miss. So when we generated that, we were looking for a package that takes most of the square, because that would tell you that for this package we are missing more tests than for any other package, right? Apparently, it's not the case. Like all those packages are very similar in size, so it means that for all those packages we are missing the same number of tests, basically. So there are no low-hanging fruits. We can't implement tests just in this particular package that is missing tests. So we need to pivot and change our approach and basically look at what we have from different perspectives, not from the package perspective, but rather from the lines of code perspective. And when you change the perspective and look at missing coverage from line perspective, and let's say that your project has like 200,000 lines of code, right? So you may say that 80% of those 200 lines of code are covered with tests, right? So that's great. like 160,000 lines of code covered with tests. Amazing, right? But on the other side, 40,000 of lines of codes are not covered with tests. So now you're starting thinking, okay, what are those lines? Do I need tests for those lines? So it's no longer like 20%, it's 40,000 something, right? So 40,000 lines of code that are missing tests. And when we understood that, we tried to like look into what this information basically tells us. Okay, and as a QAs, we work with risks, right? Like we try to mitigate risks with testing, right? We know that whenever something is implemented, a change is implemented, this change may break something, so we are testing to confirm that nothing has been broken, and this is like a risk mitigation technique. So we also wanted to like look at those lines that are missing tests from a risk perspective. So what is risk? Risk is basically, like this is the simplest definition of risk. Risk is a probability of something bad happening times the severity of this thing when it happens, right? So when bug happens, like first you need to ask like how likely it is that bug will happen, and then like how much money, for instance, or what pain it will cause your user if this bug happens, right? So those are those two factors that are required to compute risk. Or in other words, you can say that this is a frequency of something unfortunate happen and lost value, right? And this is the definition that we used for our analysis. Okay, so let's look at the first ingredient, the probability, the frequency of something bad happening. So if you looked into Git logs, who of you ever inspected logs for Git? Who of you work with Git? Okay, so you know what Git is. I'm not going to talk about that. But yeah, there is a command that you can run for a given file in your code base to find out how many this file was changed, how often this file was changed, and what are the commits for that file, like what exactly changed. And basically, when you run this command for the files in our code base, you will get something like this, right? The most important part is that every change, every message starts with Jira issue key. And this is something that we worked on. We have a naming convention for messages. Every change needs to start with Jira issue key. When developer is making a change, he's either fixing a bug or doing a story, but all those have Jira issue key, so you need to start by typing this Jira issue key into your commit message. And this helps, because now when we inspect those log messages for files in our code base, we can link them to Jira instance and to particular Jira ticket. And because we have that information, we know what types of tickets are bugs, we know how many bugs are basically committed to code base for a given period of time. So we have this information, like how often we commit or address bugs for a given period of time, just by inspecting Git. Okay, but bugs are not equal, right? You have small bugs and bigger bugs. So we needed like to take this under consideration, and we started categorizing bugs. So we said, okay, if there is a ticket that belongs to particular Jira instance and has particular priority or particular severity, it will get this score, right? And then we can like sum the total score for all the bugs happening within like 30 days, and we will have a bug score. So now we have how many bug points? How many bug points we have for a given file for a given period. And this basically was used to compute probability of bug happening whenever a change is made to a file. Okay, so this is how it looked like. So on your left, Yep, on your left, you have packages in application, still represented as rectangles. And basically, the greater size of those rectangles is, the more frequently developers commit to those packages. So you see that this pink package is like taking priority. So developers are, it's more common to commit changes to this package than to any other. On the right, you see how often bug is created or happens for a given package. And you see that there is like a correlation here. So there is also this ping package that also has like a greater number of bugs committed for a given period of time, right? So you may think that this ping package might be interesting, and I should look into this ping package and how many tests there are for that package as a QA engineer, because it looks like we are committing more bugs to that package. Okay, but let's compute bug probability. Instead of looking on those two pictures, let's compute bug probability, and this is basically bug score divided by the commit frequency. Okay, and when you do that, so when you like compare how often we commit a bug and how often we commit in general, you will see that this ping packet, ping package is no longer on the graphic. You no longer see it. And this is because, of course, we were committing very frequently to that package, and we were creating a lot of bugs to that package, but still, the ratio wasn't that bad. There is this blue package, and for this blue package, the ratio of bugs to commits is greater than for that ping packet. And when you have like this information as a QA engineer, it's like great information for you, because you now know that whenever developer commits to this package, it's more likely that he will commit a bug rather than if he decided to do a change to any other package, right? So now you want to have greater test coverage for this package. So this is something that doesn't come out of the box from the coverage reports, but you have ways to measure that. Okay, so we went through probability. Now let's go through the lost value, right? Okay, so how do you determine lost value whenever bug happens? So you may consider lost value from two different perspectives. The first perspective, and this is the one represented by Elon Musk, is like technical perspective. So a t-shirt perspective. The other perspective is a business perspective, and I don't know what this guy, who is this guy? Not Elon Musk. And let's say this is like a suit perspective, right? So we have those two perspectives that we can consider when thinking about value. Okay, so what is the t-shirt perspective? How developer considers, what is valuable for developer? Right, so developer normally codes, right? He implements a class, or she implements classes, methods in those classes, and there are other classes that calls those methods that got implemented. So you can say that value of code is how often it's referenced by other code, right? So if you have a class and this class is referenced in all other classes, you may say that this class is very valuable, and you really need to care about it, just looking from the developer perspective. So we do have packages in our application that are more valuable, like more reference than any other packages. Like for instance, this green package. Basically, this green package is like a reference in 30% of code, right? So as a QA engineer, you may say, okay, this package is used in 30% of code, so we need to also care about code coverage of this package, more than code coverage of any other package that isn't that often referenced. Okay, what about business perspective? So business cares about users. At least this is in our case, we are a product company. We developed software for developers, for our users. So we really care about them and making them happy. So what makes users happy? Providing them with tools, like useful tools, so they can apply to resolve their problems. So let's say that you have those tools. And we could, like, let's say that you have tools. Those are like your features in your application. And you have users that use those tools, right? So you have like 2 users here. They use 2 features. And because you have that information, you know which tool is most valuable, right? Like most used by the most users, right? And this is the feature in the middle. And we know that because we trace user actions. Like we know when user decides to do something in our application. We know whether user decides to create a project or decides to create an issue, right? So we know what features are the most useful, most used ones. Okay, and another way of like tracking user actions and what tools and features are most used is to inspect access logs. Who of you ever inspected access logs? Okay, so let me tell you what you can find in access logs. So every time you make a call, a HTTP request to a server, this HTTP request is logged into a file. And this is basically what you will have in that file. So let's say that you are like creating new issue in Jira. So when you inspect what is happening like underneath, you will have like a post request to certain path, and this basically creates you an issue. So in access logs, you have information what customers, by their instance names, requested particular actions. You also have information what users requested that, and the action is represented by the HTTP method and the path that you are requesting. Okay, so when you analyze what resources are the most valuable, like most frequently used, you will get something like that. And in this case, those are not packages. Those are the features, the resources that we have in Jira. Like somewhere here is like create issue resource, right? Like this is one of the rectangles. But this is probably not the most popular one. And still, the greater the size of rectangle, the most unique user it has, or the most frequently it is used compared to any other feature. So you may say now, as a QA engineer, okay, so if this resource, like this brown resource, is used like 50% of the time by users, I want to care about its coverage more than about any other resource and any other coverage for those remaining resources, right? Because there is 50% chance that someone will use that, and if we fuck something up, then we will have a problem, right? Okay. But so far we were talking about code and what to find, what kind of information to find about code. And now I started talking about like HTTP requests, like those resources, etc. So how to find connection between like those HTTP resources and code. Every time you every time you make a HTTP request call, it will be handled by a piece of Java code, like in our application, because in our case, because we are implementing a Java application. So there will be a class and method that is responsible for handling this request, right? So given that, you could analyze what is happening here whenever something gets called, right? Like what methods are called there, what classes are involved, what methods those methods call, etc., etc. And once you do that, you will come up with something like that. So at the top here, right, we have this first method that is responsible for responding to a request. And this method calls other methods in the first level. and those methods called other methods, and so on, and so on, and so on, and you have like layers and layers of code, levels of code, calls to different methods. But this is basically the representation of the HTTP request that you make, how it's reflected in code, right? And once you have that, and we did a lot of coding and scripting in order to get that information, but once you have that information, you can then pass that information to your code. And here you have packages in our application by the number of users that rely on them, right? So this is kind of interesting, because every rectangle, the size of this rectangle represents the total number of users that depend on code in that rectangle. So the greater the rectangle is, the more users depend on that code. And once you have that information, you can say, okay, I see that there are more users depending on that green code than there are on any other code. So still, I want to implement more tests for that green package, because there are more users that use it. Okay, but we were talking about risks, and I told you what a risk is. It's like you need to multiply probability by value. So let's do some math, right? Okay, so like this is like the easiest probably way you can compute risk. This is like the bug probability times number of dependent methods plus number of dependent unique users, right? You can change that to be a little bit more advanced, and also consider code you never had bugs for. And to do that, you also include like the commit frequency. So this is another way. You also care more about unique users than you care about developers that might be affected. So that's why you are putting those weights here, 0.3 and 0.7. Okay, and once you do that, you have packages that you should be interested in. Those, what you see here are packages as rectangles, and the greater the area is, the greater risk for those packages. So we have this pink guy here, and for this pink package, it's greater risk that we will introduce a bug that will affect a large number of users than it is, for instance, for this green package, right? So now we know that we want to implement tests for this pink package rather than for that green package. Okay, and as we were like coming with conclusions, and we decided to go even deeper with maths, and if coverage is a function of risk, right? And this whole presentation is about risk and showing the relation between coverage and risk. You can say that as risk is reaching 1, so like as risk is like 100%, you want to have like the most comprehensive coverage. So for the riskiest part of your code, you want to have like 100% or even more coverage. On the other side, when you have like code that doesn't have any risk, why bother implementing tests at all? Like, there isn't any data that suggests that you will cause any problems. There may not be any users that might be affected by your bugs. So let's not bother, and let's not implement tests for that package or that code. And I'm calling that Bart's test coverage efficiency, and this is restricting name. Okay, so we try to analyze how does the efficiency look like in our application. And I must say, I honestly was surprised by the results, but we are doing pretty good, because as the risk increases, so does the coverage. So for the most riskiest parts of the code, we have the greatest coverage. So that's great, and you should like aim to have it. Okay, what else? Like what other things we found out? So I started with posing this question, is 80% enough is a number between 80 and 99% of code coverage is enough? Should we aim for 100%? We can rephrase that question now when we have that data. And we can ask a different question. Are there high-risk methods that are missing tests, right, that have zero statement coverage? And apparently there are. Apparently we have 10 methods that don't have any tests, but are like amongst those most riskiest one. Are there any high-risk methods that don't have 100% coverage? And still, our data shows that we have like 50 methods that we are missing coverage for. And another question you may ask, are there high-risk methods that are missing integration tests? Because as you probably know, there is a risk relying just on unit tests. In unit tests, as was presented in the previous presentation, you mock things out, right? Like you're using test doubles, etc. The problem is that whenever you mock something, you are creating like a duplication of the code, duplication of logic, and then you need to come up with some solutions how you are going to synchronize the mocked logic with the real implementation. And sometimes you want to have at least one integration test for hundreds of unit tests. And in our case, we were missing integration tests for the 200 most risky methods. Okay, what else did we find out? We found out that we have dead code. So code that is not referenced anywhere else. Like why do keep that code? We found out that we have dead features. So features that are not used by any users. And because of that, we also found dead tests. So tests that are constantly being run on every change that either test dead code or dead features. Why bother running them if no one using this code? Why even having this code in the first place? Right? Why not remove it? We are also thinking about like improving test execution performance. Like we have this database, we know what tests go through what code. Why not run only specific tests whenever something is changed for specific code, right? And we also wanted to understand better what is the quality of our tests based on the data that we have. I will talk a bit about those two last things. So first thing, how good are your tests? Can you like answer this question? Like how would you answer this question? How do you know how good your tests are? By number of what? That's good, yeah? That's good. Let's say that you don't have that information. All right? Okay. So one way, and this is the way that I'm going to present, sorry. It's not the number of bugs. But one way of looking at how good your tests are is how specific they are. How many methods they cover. Like we want to have this pyramid, right? So we want to have unit tests. Unit tests most like very often focus just on one method, just testing this one method. So we want to have a great number of tests that focus on testing single method and a small number of tests that focus on more than one method. So we analyze that, and what you see here is distribution of tests to methods. So the biggest number, like that, we have like more than 25,000 tests that cover only from 1 to 5 methods. So that's great, right? Because this number like decreases over number of methods. So like we have only like 3,000 tests that cover more than five methods, right? So you could say that, oh, based on that finding, the quality of tests is pretty good. But if you look closer, you will find out that there is this spike here. We have around 5,000 tests. We have around 200 tests that cover 5,000 methods. Like every single test of those 200 is going through 5,000 methods, right? So those are the tests that are from the top of the pyramid. And once you know that, and once you know how much time you need to execute those tests, you can go back to your pyramid. And when I showed you the pyramid for the first time, I told you that we have a pyramid because when it comes to quantity of the tests, we have like 40,000, 10,000, etc., right? But when it comes to execution time and how much time you need to execute tests for different layers, we don't have a pyramid. We have something more like a trapeze, right? So there are these 200 tests that really take a lot of time to go through those 5,000 methods. Okay, what about the other questions? Do I need all tests to run on a change? And if you don't know, and you also need to write it down, because this is like something that is currently being discussed. There is something called test impact analysis. Who of you is familiar with test impact analysis? Oh, yeah, good. Sorry? No. Maybe not, I don't know. Maybe there is another definition. Okay, but apparently, for the past few years, Microsoft invested a lot of time to better understand what tests are exercising what code, right? And use that information to speed up test execution and choose only those tests that need to be run for particular change, right? So if you are changing a file, a Java file, you don't want to run all tests. You just want to run tests that go through that particular line. And we have all that information that is necessary, right? We have this database. We know what tests go through what class file, so we can decide what tests we want to run. And we are currently starting experimenting. We are starting to experiment with that, and because we keep all our changes in Bitbucket server. So to those of you who never work with Bitbucket server, it's just yet another application where you can store your code, but it comes with a REST API that you can call and see what changed between like your commit and master, and you basically are getting all the files that changed, right? So if you have that information, if you have database, you can decide whether and what tests you want to run. And our current algorithm is very simple. So whenever we are changing POM, right? Who of you is not familiar with POM? So POM in Java is just to manage dependencies. If you have a library, etc., you define it in POM. So whenever we are changing like dependencies, we want to run all tests. If you are not changing dependencies, but we are changing something related to web, like JavaScript or HTML, we want to run only WebDriver tests. We don't care about API tests because API tests don't exercise web application. And when we change a test, then we want definitely to run that test, right? But if it's not a test, if it's just Java change, then we are looking into this database, what tests go through that Java file and run those tests. So this is the algorithm that we are starting to use. And hopefully, it will reduce the time needed for developers to run regression tests. Okay, lessons learned. Test coverage alone isn't very useful. But this doesn't mean that you shouldn't do it. It means that you need to expand or use the test coverage report just as a starting point to better understand your business and technical angles and help come to conclusions, as I did with that presentations. Less test coverage doesn't necessarily mean that it's bad, right? You may have not covered the parts of code that aren't really that important, and that's good, right? I would even say that if you have more coverage, it doesn't necessarily need to mean that you are better, right? Because you may focusing your effort on implementing automated tests that exercise parts of code that aren't used by any developers and aren't used by your users. Don't close yourself to automated tests. As I said, I'm not implementing automated tests myself. If you don't want to do it as well, apply to Spartez. Okay, this one is important. Statistics is hard, percentiles are hard, but still, it's really nice to spend some time understanding better what's happening. And coverage enables test impact analysis, so helps you determine what tests you need to run for what changes. Okay, thanks.